Right, so there's two substitution reactions that you need to know about. The first of which you'll end up forming an alcohol. So what happens is you mix a haloalkane. So if we just keep something simple like bromomethane, and we mix it with aqueous hydroxide. So just some sort of hydroxide, sodium hydroxide, potassium hydroxide, whatever it is, dissolved in some water, and you end up substituting the Br for the OH. So you get you can also test for an alcohol by doing this reaction and then adding silver to it. So if you add silver ions like you did last year to this solution here, it will react with the bromine or the chlorine or whatever it is. So they'll react together and you'll get some sort of silver halide. So in this case, it will be silver bromide, which is insoluble. So it ends up forming a solid, which you can see as a precipitate in the solution. So the second substitution reaction, you end up forming an amine. Okay. So, and it's a substitution reaction. So if we start off with chloroethane, and we are going to react it with alcoholic NH3. So the reason we do it with ammonia dissolved in alcohol, because if we did it with water, there would be lots of OH ions available, so you would end up actually substituting the OH for the Cl and you wouldn't form an amine. So you actually have to do it where there's no extra OH ions, like in the previous reaction. So you do it with ammonia dissolved in alcohol and you end up forming an amine. So in this case, when we react these two together, so we switch these two around, remembering that nitrogen can only have 3 bonds, so it's used up one of the bonds there. So we end up with NH2 plus HCl. So one of the hydrogens came from the ammonia so that it could form a bond between the carbon and hydrogen, and then the chlorine came from there when we switched it out. As with alcohols, you can also eliminate haloalkanes. The reagent that we use is a hydroxide ion dissolved in alcohol. Again, if we do it when it's dissolved in water, there's too many OHs available, so it would just be a substitution reaction. But when we do it in an alcohol, it ends up being an elimination. So if we add alcoholic OH to something like 1-bromopropane, so we add these two things together, we are going to eliminate the bromine and a hydrogen from an adjacent carbon. Now, if you look at this, I've drawn it a little bit confusing, but this is the carbon that the bromine's joined to, so the carbon that is adjacent to that is this one here. So my product would look like something like that. We have a side product of HBr, and then we have 2 spare bonds here, which we can't have because it's very unstable, so we end up with an alkene. I'll draw that so it's a little bit easier to see. So if I redraw it like this, you can see that here is my bromine, and I need to take the hydrogen from the adjacent carbon. Again, my Markovnikovs, or anti-Markovnikovs, so anti-Markovnikov's law applies. So if you need to see that, go back to look at the elimination of alcohol's law, just to review that.